Okay, so I have here my big ass TI 80 whatever calculator. And then over there I have my bonus problem that I'm supposed to solve. Y prime is this matrix times y. Matrix is 2, 2, minus 2. Oh, what the heck. I'm going to put that in here because I'm going to need that. So if I go into second, and then there's this matrix button down here. And then I want to go over and I want to edit matrix A, and I want it to be a 3 by 3 matrix, and it needs to be
that's it.
that one. Dude! 2, 2, negative 2, 5, 1, negative 3, and 1, 5, negative 3? Yes! Thank you for saving me some time. Okay, so when you look at this, you should be thinking to yourself, okay, the answer to such a thing is probably y is e to the at, maybe with some vector of constants slapped on there. Okay, so I need to figure out what e to the at is, and I go to a power series expansion for that. So first things first, it's the identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Yeah.
Yeah.
Plus what?
0. Or the first term or whatever.
Okay, so I'm kind of thinking here. This is like e to the x, right? E to something, at least, is 1 plus, this should be an x, right? This is really just, I'm kind of looking at this and I'm thinking about the Taylor series for e to the x, which is 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial, and kind of so on, right?
So the next one A then?
Yeah, so the next one should be at, right? Because x is really at.
A squared, t squared.
So this guy should be my matrix 2, 2, minus 2, 5, 1, minus 3, 1, 5, minus 3 times t. And then my next one should be
A squared, t squared.
a squared, t squared.
Is that over 2?
Yeah. Yeah, and the t squared is going to be over 2, right? Don't divide the matrix by 2.
Did you want us to square the matrix at all?
Yeah, so I need to square this, right?
Yeah.
So there's an easy way to square it, hence the calculator. Get out of the matrix mode,
Go back in there.
go back in it, get A,
Square it.
yeah, and then actually the power functions just work. So square it. So I get the matrix 12, negative 4, negative 4, 12, negative 4, negative 4, and 24, negative 8, negative 8. You guys with me? And then your next term is going to be that cubed times t cubed over.
Actually, that cube would just be 0. Huh?
Yeah, not this, but a cubed, right?
Yeah.
So I need to go back into my entry, and I need to make this not a squared, but a cubed, and that's all zeros. So this matrix was nilpotent, right? So all the rest of the terms in this power series expansion are 0. You guys see that? So my solution to this is y is that whole matrix, right? So I'm just going to collect things quick. So the top left term is 1 plus
2 plus 12.
close. It's not quite that simple. You got to get the t's.
Oh.
So you got to do the scalar multiplication.
12t.
So it's 1
60
plus
squared?
2t plus
Is it 60
6t squared. So that's my first top left entry. You see that? Then my middle top entry is 0 plus 2t plus, oops, minus, thank you, minus 2t squared.
Yeah, 2t squared.
And then my next term is minus 2t minus 2t squared. See that? Okay. And my next one, collecting, is
1 plus 5t.
I think I got it. 5t plus 0,
Oh,
right?
yeah. 0 plus 5t.
Plus 6t squared. And then my middle one is 1 plus t
Minus 2t squared.
minus 2t squared. You guys see this? And you could probably try to get the calculator to do this. It depends on how smart your calculator is, whether it'll hold those t's in there for you or not. Let's see, and then my next one is going to be a 0 minus 3t minus 2t squared. And then my bottom row, real quick and in a hurry, is t plus 12t squared, 5t minus 4t squared, and 1 minus 3t minus 4t squared. And that whole matrix times,
C.
yeah, vector of constants, right? So if you wanted to write this out in kind of like another format, you might write your vector y is really the three functions you were looking for, right? y1, y2, and y3. And then your vector c is c1, c2, and c3. Guys, kind of with me on this? Check done, solved.
Is this how we're going to do it on the test, or are we going to do the book thing, or?
So if I enlighten you that a matrix is nilpotent, or if you know something about it, like that it's nilpotent, for instance, this is probably the one I'm going to give you. If we had more time, I'd show you how to do this with diagonal matrices too. But I don't, so yeah. If you knew that this was of a special form that was convenient, and in your case that's only nilpotent, then you could do this approach, or you can try the other thing. The other thing for this one will kind of suck, because there's a repeated eigenvalue in here, so you have to like figure out how to deal with a generalized eigenvector, and it's really just a pain. But if you know it's nilpotent, like you just cram it in the power series expansion and little calculator. I guess that's the wrong gesture for calculator. Little computer work. Cool.
So is there any way to actually solve for the C's right here, or this is the final answer?
If we had initial conditions, we could solve for the C's.
Okay.
If we don't have initial conditions, then we should have a general solution, right? And so this is your
Would we have? Could we have a possibility of like y1, y2, and y3 initial conditions, or would it just be like a y vector initial condition?
So depending on,
Do you get what I mean?
yeah, so it would certainly be reasonable for me to tell you, like, y evaluated at 0 is 1 and 2 and 3 or something.
Mm-hmm.
But that's the exact same thing as me telling you that y1 at 0 is 1,
And y2 is
and
2.
y2 at 0 is 2, and y3 at 0 is 3. Like, those are interchangeable.
Okay, so that makes sense.
And depending on where this thing came from, you might have to supply a little bit of that. Like if this was a higher order differential equation that we turned into a system, then we might have to like back translate. Remember how we did those, like, we made a bunch of substitutions? Like if I had y2 was actually y1 prime, then I wouldn't be expecting to see a condition on y2, I'd be expecting to see y1 prime. You guys see that? So you might have to do a little renaming, essentially. And then, of course, all of this, if you're making the system, is up to reordering as well. Cool? Does that kind of help? I think the book gives you initial conditions this way in the homework, but this would also be a valid option. They're not going to have you do higher order things quite like this yet. Cool?